Well, we can also define an inverse cosine function, but again we must restrict the cosine of function itself because it's not a one-to-one function. So here on the left we have a picture of the restricted cosine function, which equals cosine of x if x is between 0 and pi and it's undefined otherwise. And cosine inverse of x, or arc cosine of x, is the inverse of this restricted cosine function. So on the right here we have the graph of the restricted cosine function in red and its inverse function, which is arc cosine of x, in blue. And of course this restricted cosine function satisfies the horizontal line test, so therefore it's a one-to-one function and it's legitimate to create this inverse function. We can see that the domain and range get switched. The domain of the restricted cosine function is from 0 to pi, so therefore the range of the inverse cosine is also 0 to pi, a set of angles between 0 and pi. And the range of the restricted cosine is from -1 to 1, so therefore the domain of cosine inverse is from -1 to 1. It's all numbers between -1 and 1. We also have our equations. The translates of f inverse of x equals y is the same as f of y equals x, but again we have to be careful that f is a restricted function with a restricted domain. These translate to cosine inverse of x is y is the same as saying a cosine of y equals x, and y is an angle between 0 and pi. And also we have cosine of cosine inverse of x is always equal to x for any x between -1 and 1, as long as it's legitimate to calculate cosine inverse of x, then we have cosine of cosine inverse of x is x. On the other hand, cosine inverse of cosine of x is x only for x in the domain of the restricted cosine function between 0 and pi. So we have to be very, very careful with this equation on the right. Before we state that cosine inverse of cosine of x is x, we must be very sure that the angle is between 0 and pi. Otherwise, we're best to calculate this from the inside out. Well, as before with the inverse sine function, we can use implicit differentiation to calculate the derivative with respect to x of cosine inverse of x. And what we find is that it's minus the derivative with respect to x of sine inverse of x, or that's equal to the derivative with respect to x of minus sine inverse of x. So it's equal to -1 over the square root of 1 minus x squared. And of course you know from calculus 1 that because the derivatives of these two functions are the same, we must have that they're related by a constant. So therefore cosine inverse must equal minus sine inverse plus a constant, and we could plug in x equals 0 here to find the value of that constant, and we see that it's pi over 2. So we have that cosine inverse of x isn't really a new function. It's equal to minus sine inverse of x plus pi over 2. Now we can also create an inverse tangent function, also called arctangent of x. And once again we have to restrict the domain of the tangent function to make it a one-to-one function. So our restricted tangent function is the piecewise defined function h of x. It equals tangent of x for x between minus pi over 2 and pi over 2, and otherwise it's just undefined. And we see from its graph that the function is one-to-one and it has an inverse, and we call that inverse tan inverse of x or arctangent of x. So here on the left we have the graph of the restricted tangent function in blue, and on the right we have the graph of its inverse, which of course we get by reflecting the graph of the restricted tangent function in the diagonal of the plane in the line y equals x. We see that the range and the domain get switched, so the range of our tangent is that restricted domain from minus pi over 2 to pi over 2 of the restricted tangent function, and the domain of the arctangent function is the range of the restricted tangent function, which is everything from minus infinity to infinity. So tan inverse of x can be applied to any number between minus infinity to infinity, and the result is an angle between minus pi over 2 and pi over 2. Putting together what we know from our theory of inverse functions, we know the domain of tan inverse is all numbers from minus infinity to infinity. Its range is all angles from minus pi over 2 to pi over 2. Using the equations h inverse of x equals y, if and only if h of y equals x, we get that tan inverse of x equals y is the same as saying that tan of y equals x, and y is between minus pi over 2 and pi over 2. Since h of h inverse of x is x and h inverse of h of x is x, we again have the two equations. Tangent of tan inverse of x is always x for any value of x, but tan inverse of tan of x is only x for x in the open interval from minus pi over 2 to pi over 2. And we also see that tan inverse is an odd function, so tan inverse of minus x is minus tan inverse of x, and this is very useful when we're doing calculations. We can also see that the graph of tan inverse has two horizontal asymptotes. So the limit as x tends to infinity of tan inverse of x is pi over 2, and the limit as x tends to minus infinity of tan inverse of x is pi over 2. And of course these come from the limits that as x tends to pi over 2 from the left and x tends to minus pi over 2 from the right, tangent of x goes to infinity. Let's do some calculations. How would I find tan inverse of 1 and tan inverse of 1 over the square root of 3? And tan inverse of 1 is that unique angle theta between minus pi over 2 and pi over 2 with tangent of theta equal to 1. You could inspect your unit circle if you like, but for the most part you should remember that tangent of pi over 4 equals 1, and we see pi over 4 is this unique angle between minus pi over 2 and pi over 2 with tangent of theta equal to 1. For tan inverse 1 over the square root of 3, we're looking for that unique angle between minus pi over 2 and pi over 2 with tangent of theta equal to 1 over the square root of 3. And tangent of theta is sine of theta over cosine of theta. Checking out the unit circle here, we see that theta has to be pi over 6. It's this unique angle between minus pi over 2 and pi over 2, where sine of theta over cosine of theta is equal to 1 over the square root of 3. Let's look at something slightly more complex here. Suppose we want to find cosine of tan inverse of 1 over the square root of 3. Then we should evaluate from the inside out. So cosine of tan inverse of 1 over the square root of 3 is cosine pi over 6 by our previous calculation, which is equal to the square root of 3 over 2.